Okay, now for question 6, we have here that in the figure, point P, it's right here, is at rest on the x-axis, right there. The time t when P returns to the original position the x-axis is closest to. So basically it's telling us what's the time when P goes all around here and returns right where it was. So as we know, if it goes all around there, that's going to be 2 pi because it does a full circle. It returns right to where it was, 360, right? So knowing that, we know that we're working a with a constant angular acceleration, and the equation for that is going to be, I kind of worked with this a bit already, but it's alpha times the initial the angle times the initial angle plus the angular acceleration, the initial angular acceleration times time plus half of alpha times time squared, right? So basically they tell us that this is going to be 0, this is going to be 0, and then we're just left with this. Alpha is just equal to that, and we know that theta is going to be 2 pi. Oops, sorry, let me move this back to where it was. And that's it. So then once we already know that, we can just solve for time, for t squared. And once you do that, once you already solve for t squared, you just plug in the numbers that you get, right? We already know what the alpha is. It tells us right there. It's 0.010, and we know that we know the rest of it, right? It's 12.28. So that should be that once we solve for t, it should be around 35 seconds, right? So it should be E.